Good day. Today we're going to look at another method of integrating. Let's say we have a function such that it's the integral of x e to the x dx. Now if we have to integrate this function, now so far we have done direct integration, integration by substitution, and integration by partial fractions. Now this function itself cannot be integrated directly using any formula that we know. We cannot use a substitution, and this is not for partial fraction. But what we can identify with is that this integral is really a product of two functions. So in order to integrate it, what we're going to first figure out is how we derive the formula to integrate a product of two functions. And this leads us to the differentiation using the product rule. So if you recall the product rule, it says if u and v were functions of x, then the derivative of uv was v du dx plus u dv dx. Now, if we integrate both sides with respect to x, what do we end up with? We end up with, now the integral of a derivative is just the function, so this is uv is equal to the integral of v du dx with respect to x plus the integral of u dv dx with respect to x. So if we make either integral subject of the formula, and let's say we just use the v du dx, what do we get? We get that the integral of v du dx with respect to x is equal to, well, it's uv, we're going to evaluate this, minus the integral of u dv dx with respect to x. And this is known as the integration by parts formula. So whenever we have a product to integrate, we use integration by parts to integrate a specific function. So let's get back to the question, the original example that we had, the integral of e to the e to the x dx. So we first have to establish what is our dv and our du dx. In the first scenario, what we're going to do is to let v equal to x and our du dx be equal to e to the x. So dv dx is equal to 1 and our u is equal to e to the x. So therefore, the integral of x e to the x dx is equal to uv, so that's x e to the x, minus now the integral of u dv dx, so that is e to the x dx. And this simplifies to x e to the x minus, well, the integral of e to the x is e to the x plus c. And this is how we integrate the product of x multiplied by e to the x. I know sometimes when you think about it, you want to integrate x separately and then e to the x. No, you have to use integration by parts to work out this type of integral. So let's look at another example. Let's say we have the integral of x cos x dx. Again, we're going to let our v equal to x and our du dx equal to cos x. Now, why do we choose v to be x? Well, it's easy. When we differentiate v, we'll get a constant. And when we integrate the u, we will get another variable. Alright, so it's easier to find or use v as a function that differentiates very quickly to a constant. There are some cases where it doesn't matter and some cases where it does matter. In these cases, where you have x cos x, x e to the x, it's convenient in a sense to use v is equal to x. So if we let v equal to x again, dv is equal to dv dx is equal to 1 and u is equal to sine x. So therefore the integral of x cos x dx, that is going to be equal to, again it's uv, so it's x sine x in square brackets minus now the integral of u dv dx, which is sine x dx. And it's now x sine x. And the integral of sine x is minus cos x plus c. So our final answer is x sine x plus cos x plus c. Another example that would really pique some attention is this one. It's integral of it's integral of e to the x cos x. Now, as was mentioned before, we try to choose the variable for v, or the expression for v, which differentiates very quickly to a constant. But in this scenario, what we see is that if you differentiate e to the x, you will always get e to the x. And if you differentiate cos x, you're going to get minus sine x. And if you differentiate minus sine x, you get minus cos x. And it continues into a loop. So in this scenario, it really doesn't matter which function we use as v and which one we use as du dx. So let's use v as e to the x and du dx, that's equal to cos x. So dv dx is equal to e to the x and u is equal to sine x. So therefore the integral of e to the x cos x dx is equal to uv, which is e to the x sine x, minus the integral of e to the x sine x. And you realize now we started off with integrating e to the x cos x, and now we end up with integrating now e to the x sine x. So what we have to do at this point is to integrate e to the x sine x again by parts. So if we let, again, we're going to use v we're going to integrate by parts, but this time we're going to change up the variables. We're going to let v1 equal to e to the x. So du1 dx is equal to sine x. So now our dv1 dx is equal to e to the x, and our u1 is equal to minus cos x. So the integral of e to the x sine x dx is equal to, again, v1 u1, so that is minus e to the x cos x, minus now the integral of e to the x by minus cos x dx. Which is equal to minus e to the x cos x plus integral of e to the x cos x. So we are now going to substitute what we have just integrated back into the integral of e to the x cos x. So the integral of e to the x cos x dx, it's equal to e to the x sine x minus, well, it's minus e to the x cos x plus integral of e to the x cos x dx. Very strange though, because we started off integrating e to the x cos x and we end up, we come back to a situation where we have integral of e to the x cos x again. So if we simplify, I'm going to treat with that shortly. If we simplify now, we're going to get this, the integral of e to the x cos x is equal to the integral of e to the x sine x plus e to the x cos x minus the integral of e to the x cos x dx. And we're going to take this integral across on to the left hand side. So the left hand side now becomes 2 times the integral of e to the x cos x dx is equal to e to the x into sine x plus cos x. And then we divide by 2. So therefore, the integral of e to the x cos x dx is equal to e to the x over 2 into sine x plus cos x. Okay. So this ends our short class on integration by parts. I hope you have enjoyed the session and you all will have learned how to integrate by parts.